Yes, thank you. So I wanted to just talk a little bit. I want to tell you a little bit of a story. So this is MegaHit is a scientific program. It's used for DNA assembly. So the idea is that you have sequences of DNA, and they're in these little small segments called reads. And then what happens is the software assembles the different reads into longer continuous sequences. And then the result at the end is you have this kind of long sequence of reads. And so this is how it works. It's scientific software, and it's used by many, many people. And there are many different versions of it. I'm going to talk about a version that happens to wrap another version. So it has a nice GUI. So suppose we take a scientist. She happens to be a Nobel Prize winner, so we think she's probably pretty intelligent, and she can work with the software. So she's going to use this MegaHit. She wasn't part of the real story, but this is a real story. And in this software, at the top, we just put in some set of reads, and these happen to be from a plant sequence. And you notice here that we have several, what I'm going to call configuration options or parameters, so things called min count, kmin, kmax, kstep, and we find these in all software. But she does what most of the scientists will probably do first. And so she said, let me just run this and find out what the software will do. And when she does that, she gets some number of contigs, which is the final result of this tool, and she has this number 284. However, as I said, she's pretty bright, and so she happened to go and look at the log. So this is a GUI environment, and there's a real system, and if she had just used the system and walked away, she would have been done. But she happened to notice that in the log, there was this little message that was hidden that said Kmax was reset to 119. Now, she used default values, so she really didn't even know what was happening here. So she went back and said, okay, well, let me just try this again, but now I'm just going to set Kmax to 119 because that's what it told me it did. So she ran the query again. She got 285. Oops, there's a problem. Okay, so, but as I said, she's really with it. She's a very strong biologist, and she said, let me just go now read the documentation. So she read the documentation and put in all the default values. So these are the default values, and it turns out that Kmax, the default value is 141, but that should match what's in that first column, right? So she ran it again, and she got 285 again. Okay, so this is getting frustrating. So then she started doing a little more investigation and realized it turns out that this sequence came from a tutorial, and the sequence itself wasn't 119 long. It was less than that. So instead, she left all the default values, but restricted it to 99 because maybe there was some bug related to the length of the sequence, and ran it again. Now she got 289. So she's run this tool 4 times, and she has 4 different answers. And you're probably thinking, this is not unusual. I've seen this before. So I actually went and looked. This was a real scenario that happened. She wasn't part of it. And I went and looked up what happened. So we talked to developers about this, and it turned out there were several things. So first of all, there was incorrect documentation. The default for K-step wasn't actually 12, it was 10. So they had forgotten to update their documentation. There were also hidden dependencies. So it turned out that there's this other parameter, which we don't see, called K-list. And that has a list, and you notice that 119 is there. And it turned out there were dependencies between the K-min, K-max, and that's how it chose the 119, but that was sort of hidden. And then the third thing is that there was actually a constraint, a hidden constraint. So if you went further, you would find out that there was this limit on the size of Kmax, and that it also had to be an odd number. So all these constraints, and none of this was available to this user. So as programmers, we've seen this a lot. This is a very common thing, and in fact, most of our software we see today is configurable. So something like Firefox, LibreOffice. This is actually a surgical robot system. When I've worked with some developers of robot systems, and they're configurable. They all have these different options we can change. So let me tell you another story that's not from biology, because many of you are probably more familiar with it. Apache. So there's a well-known exploit which is called options bleed, and so bleed is telling you that it's bleeding memory. So you're actually there's a leak in memory that you can get. And the way this happens is when you happen to provide an unknown HTTP method that hasn't been loaded into the system, it doesn't get built, and it has a use after free bug, and that causes memory to leak. So here's an example of how this can actually happen. So here's a limit method. And what limit does is in Apache says only allow these to be used in this system. So it's limiting to put, delete, and bind, except you might notice here that by mistake, the programmer put the wrong spelling of delete. And so if you run this code, if this is inside your HTTAccess file, what will happen is now delete doesn't exist. And in that case, it will bleed. Here's another example, a little more complicated. So bind was also in that last example, and it won't bleed if it's been configured. So it turns out that bind is only available if these two other steps are made. So you have to configure it using this enable dev, and then you have to actually run a command. And if that's the case, it won't bleed, otherwise it will. So these are kind of complicated things that happen. So I'm probably not telling you anything you've heard. There's a lot of research on configurations. I would say it's pretty much everywhere. So I'm going to start with a little story that before the pandemic, I had a colleague that I met. We started at the same time, my most recent position, and he works in file systems. So he works in file storage, completely different. And we happened to meet up last year. Finally, we could see each other again. And I said, oh, what have you been working on? And he handed me a paper. And the paper is Understanding Configuration Dependencies of File Systems. And they're doing static analysis to do dependencies. So essentially, he's doing the same work that many people in my community are doing, but this got published in a hot storage paper. And if we keep looking, we see that there's papers on this in the cloud systems. There's others just looking at static analysis. Here's more on security area. So we can keep going. HCI, people in the community that are looking at prediction of non-functional properties, hyperparameter tuning. So those are just configurations if you think about what's happening in an AI system. And it keeps going. So I'm going to keep going. And as I said, if your favorite paper's not here, there's too many to put here. But this is the problem, right? There are papers everywhere, and many of them are solving the same problem, and they're solving it over and over again. And that's really why we started to think about this essay. So I want to credit Mary, because this morning she gave me I had to change my slides, because one of her slides this morning, this is a screenshot, said that almost half a century ago, they realized that configurations of modules is not supported by traditional languages and offered a regular language. And it said, this has evolved into notations for system configurations and software architectures, but the integration with programming languages remains tenuous. So I had to add that slide because this is one of the points of why we want to talk about this essay and talk to this community about what's going on. Okay, so we've been talking about configurations, and there's a lot of terms that are they're thrown around. So Paul and I have spent many Zoom meetings this last year talking about what's the definition. We hear this word misconfiguration, and some papers use the word misconfiguration, but then some people in my community use variability, variability fault, and I can tell you that we don't have an answer yet. So we've spent hours and hours. So I went and tried to look up some definitions. So there's a definition for misconfiguration. This actually comes from NIST, and it says an incorrect or suboptimal configuration of an information system or system component that may lead to vulnerabilities. So if you look at their definition, it's only about security and it's about vulnerabilities. However, I think that's probably limited. But in the security community, this is really important. And a lot of this is, this research is now going to things like to the Usenix community. So if we look at OWASP, which is for securities, and we look at their top 10, you can see that security misconfiguration moved from number 6 up to number 5 last year. So it's a really important problem, and they have it as one of their main categories that they keep looking at. And this is between 2017 and 21. So there have been tons and tons of solutions that people have been working on. So people are doing static analysis. They're reverse engineering the configurations of dependencies. They might have found that problem in that bioinformatics tool. They're doing, a lot of people in my area are doing testing or doing sampling. So we have these very large configuration spaces. We want to figure out how we can reason about the space, but by sampling it because we can't exhaustively analyze it. There's something called configuration-aware testing. People are doing a lot of, for performance tuning, they're using a lot of prediction tools, using ML, and they're doing transfer learning across configurations, and that research kind of continues. The problem is, if I want to now do something in this area, so if I go back to my colleague who was in file systems, where does he go? How does he find all the research on configurations? You start reading it, you find a new problem, but what am I going to do about it? So who's working on it? Well, people in AI, educators, human-computer interaction, industry, networking systems, programming languages, security, software engineering, and we're all in different places. So how do you actually find this? And even we've seen a tweet recently about this. So we're seeing it everywhere. This is more in the PL community. So here's different dimensions that we might have. So you think about it, this is the problem. So we have domains. So it's in business domain, it's in mobile, parallel. I just showed you scientific, security, systems, learning. So it's in many, many different domains. The impact can be correctness, but it can also be performance, safety, security, usability. So configurations can cause usability problems. And then there's many different stakeholders. So I showed you an end user, but there are developers, researchers, sysadmin, test engineers. All of them have stakes in configurability. And we kind of looked at this, and we looked at many different kinds of bugs, because as I said, we have this idea of, we have this misconfiguration. So we sat down and we spent hours going through different examples of kinds of misconfigurations or faults. We said, where do they belong? Where do they fit inside of this sort of cube, or what kinds of faults are they? Are they really misconfigurations? So you might see things, for instance, so here's some examples of plain text logging, which can be a fault, a security fault. And the problem is it's in the user specification, and we might call that like a user configuration misuse. So the user is actually misconfiguring there. Or we might see a privilege escalation that came from a software configuration misuse. So these are kind of misuses. But then we see things, so there's been work on, for instance, unimplemented configurations. So you may have an option in your system, and this is some work that we did, and then you evolve the system, you remove the implementation, but then you leave that option there. So now you have an implementation bug, or the actual configuration itself is not correct, it's implemented wrong. And then you can have just regular, what we call variability bugs, which are just faults that only appear under certain combinations of configurations. So it's pretty broad, and for now we're calling all of these misconfigurations, but I don't want to commit to that because I don't think we really know. We also tried to look at, so what types of faults and where they fit. So here's kind of the same view. So we have the configurations can be at the user specification level. They can be at the developer level. It can be where we're implementing them, or it could just simply be in the code. It could be a regular fault, just what you would think of as a bug, but something that's hiding in a combination of configurations. And then what's a little more tricky, at that very bottom, we have this word variant, because all these ones at the top kind of assume that maybe the system is dynamically being configured, but often you configure a system and you release just a variant of it. And now that's really hidden because individual variants, so it looks just like a program bug, but it's just an individual variance. And we also see these across different life cycles. So we see them in requirements, development, maintenance, testing, system deployment. And if you think about, again, we have all these researchers solving problems, and they all have the same problems, large exponential spaces, trying to reason about this variability, and they're all in different places. So, we looked at this, spent a bunch of time, and we said, okay, well, let's go to ACM, because ACM is going to solve our problem. So ACM has CCS, and every time I write a paper, I have to go and put down where, and I actually know the answer to this, but we said, let's just look at this again. And I've spent a long time looking through. It's not very easy to go through. And you, of course, find the software configuration management and version control systems. In fact, this particular code has snuck into some of the hot CRP systems. And when you go to write a paper on configurability, sometimes you don't even have it. You have this choice if you're working in configurations. People have gotten better, but sometimes they sort of pull these over. Okay, so software configuration management. Well, there's got to be something else, right? Okay, well, Mary mentioned this again this morning. She actually mentioned the word feature interaction. So if you're thinking about the kinds of faults that I talked about, those variability bugs, many people talk about them as feature interactions. But at least in my community, I work in testing. There's some people don't call feature interactions in my community one thing, but other people that in requirements engineering think about feature interactions from a different perspective from the requirements. So I think about them at sort of the code level, they think about the requirements, and actually we don't always agree. But there is a feature interaction, but it doesn't handle everything. That feature interaction is not going to handle what we saw, for instance, in that biosoftware. And then there's this other one, which is a very specific type of configurability called software product lines. So software product lines are sort of managed families of software, and somehow they manage to get their area into the CCS. But I can tell you can look, and I can't find anything general about configurability. So if I want to go find the research for configurability, I'm stuck. I can't find it all. So really the point of writing this essay and thinking about it was, well, what if? What could we actually do? So what if configure options were first class? And I want to be careful because I'm in a programming languages community, and I know that it's been worked on, right? This is not something that there was a really good attempt, this thing called variation calculus, that tried to do things. There's other attempts, I won't go into all of it, but many of those were at the very sort of low level. And I'm going to go back to this morning because they were talking about these mathematical representations, and it's okay, but think about the person who's trying to reason about configurations from the end user perspective, or from just even developing. We need higher level abstractions. So maybe we want to think about the system and treat them as the first class, but we don't need maybe those low level constructs, or we want to build something on top of that to help us. So what if we had that? So here's our first attempt at this. So this is actually coming out of the Doxygen system, which is just a documentation system, and it builds Java doc-like code. It happens to be using BusyBox, which is just a set of Unix utilities, if you're not familiar with that. And at the bottom, you can see there's this section here called config. So this is what you typically would get out of. So what Doxygen does, it goes and there are certain tags, and it actually pulls those comments out. It finds your comments, looks at tags, and pulls them up, and it documents them. So here we've added this little piece to Doxygen where it actually gives us the name of this configuration. It gives us a default value, a short description, a long description. We actually reverse engineered this particular one. So this is actually something we just got automatically from the system. But we could also, for instance, have tags. So we might have things like config or C-type or value or prompt. So all these were starting with C's to mean they're related to our configs. And we could actually put our default values in here. We could put our constraints. So here we could potentially put all of that information that we wanted to give to the biologist as documentation on top of it. And now the other thing that we would have is we might even have more information, and I'll go to the next slide to show you that we call traceability. So we're looking here at the different parts of that, one of these files for BusyBox, the one that we documented. And if we look here, you can see in the code, it's asking, it has an if we've enabled the long options, and this is where the documentation is going to go. This is actually inside that file, which is this Dell user file. And what it's done is it's actually gone and it's traced it back to where it's defined. So there's this config in file, which sits at the top of BusyBox, and it's actually defining the long options there. And so it's pulling information from there, and it's tracing it for us, and it's telling us it's defined at line 62 there. We now have that information in this file, and we can actually add more. So we can actually get built-in traceability. So not only would we have the documentation and we'd know everywhere it's used, but then it would kind of trace it to all of those locations where it's being used. So, maybe this is just a first step. I'm not sure, but we're really trying to think, what can we actually do? So went back and we said, okay, so who are all the people? How can we reach some sort of common ground here? We had all these people in the community that are all working in configurability. So, kind of the obvious thing. So the first thing we thought of was, let's just, we need a community. So we're going to give it a nice name. We'll call it Accord because that sounds nice. And we're going to call it a community for configurability, open research and development. So this is our first idea. And we can build this and we can have lots of experimental artifacts, benchmarks, tutorials, tools, best practices, communication. You don't have to go to ACM, you just go find a chord and you have all of that information in one place. But I don't know if this is really gonna work. And this is kind of our idea. So we'll just leave it there and see what you think. I mean, this is just something that maybe could work, but we're not really sure. So in the ideal world, we have a way for all of us to work together. We'd all contribute, we'd share ideas, solutions, tools, and we'd build variability into all the languages. They'd be self-documenting, and we would have traceability down to all of where the options are, and we would know exactly what's happening with configurability. But the problem is, why would everybody do that? I mean, you have to create value to make this happen, right? Each of the communities has to feel that there's something that they're getting out of it that they can actually benefit from the other communities. So here's the real world. I just copied this briefly from ACM. There's many more conferences, but I'm sure if I looked at all these different conferences and they all are on different topics, we'd find something on configurability in each one of them. So the problem is we're all in different communities. We're all publishing in our own communities. We're working in our own communities. So why do we want to actually get together and share this? So, we just gave a couple of examples. We thought about it. Well, what about the systems community? So if I go back to that file systems example, well, there's probably a lot of tools they could have leveraged, built-in static analyses that already do a lot of what they want to do, and maybe they could have done a lot more with that. So they could have gone to the next step. They could work with the PL community to leverage representations about their problems, and they could give back to the community by providing large real-world data sets for us. So these really large systems. I mean, I'm actually very interested. I keep bringing up the file system one, but I'm very interested, and I think it's a unique case, and they could give us these large systems, and we could work with it. Scientific community. So I just showed you some bio stuff. They can benefit by leveraging pre-built solutions. End users can be more aware of impacts of changing options. So maybe we need recommender systems. We need ways to help that biologist understand what those options are and what they're going to do, rather than hiding things in logs so that they just use them without worrying about what's happening. And again, they can provide interesting use cases and challenges for us. And I've put the PL community last here, but this gives us more real-world, large-scale, often multilingual problems, so things that are interesting to work on. There are big challenges for end-to-end analyses. Many of these configurable systems include lots of different components that are coming from different places, have lots of different ways. In a traditional configurable system, you don't just have a nice, neat one file that defines all the configurability. It's usually spread out, so there's some really interesting challenges for you. And you could fundamentally change the landscape of configurability research. So if I could get my Doxygen tool and just use it, you could actually be helping everybody. So I've shown you that we have clearly some work to do in the world of configurability. We have research everywhere. We have thought about some things we might be able to do. And I don't have the last one because I can't really conclude without hearing what everybody here wants to say. So I'll leave that blank and just let's chat.
Thank you.
Do you want to bring Paul on? So is he on?
Yes. Let's see.
How do I
One
escape out of
possibility
here?
would, yes, and then show the.
Because he told me he'd answer all the questions. Oh, there he is. Okay.
Yeah. Okay. Perfect. I think if you go out of sharing your screen, if you press the don't share screen button, then he will get bigger.
Okay. Oh,
Yeah,
right. Okay,
perfect.
we see you, Paul. You're here.
Thank you. This was a really interesting presentation. Also reminded me of an itch that I had for a project that has started 10 years. I saw this get-opt code. So people still have to write a lot of low-level code to manually parse configuration options. And I didn't want to do that, so I made basically an annotation-based DSL for Scala, where if you need an integer, you declare an integer in the right place, and the rest with reflection would be discovered at runtime that there is an integer. It would generate the syntax for parsing it. It would check bounds and even simple dependencies. But then I never found a place to publish it and forgot about it. It was kind of a part of a bigger project. So even though this was quite new technology 10 years ago, it still is today. I never had the time to publish it. There's never quite the right venue. There are Scala events, but then it's more than just for Scala. So I thought, okay, maybe that's not the right community. Couldn't quite find the right community. So I think there is a need for a community and events around this. I definitely agree.
And there are some workshops. So there is, so you have, or some conferences. So you have the software product line community. You have BOMOS, which is variability. And then there's a community which is called configuration. So I recently ran into some people in that community, and they work on a different aspect, but they're still working on different pieces. Yes. So Paul, you may want to say something about it, because I know you're doing more analysis of those options and if defs and stuff. So I'll let you, if you want to.
Yeah, I mean, I guess. Well, I think that is the issue, is that it's very hard to find a place for the work, and work like that really sounds like PL work. But you find more of the publication of this sort of pure configuration stuff in the software engineering world, because there's this what I think is a bit of an artificial divide between the programming language proper, like C, and the software infrastructure languages, like the build system languages. And so these are, because of the whole push for DevOps and more automation, these are really getting blurred. I mean, object orientation itself is almost like it's a software architecture design specification in a sense, but it's embedded in the programming language. And there are, you can imagine more of this being considered programming languages, like including makefiles and bash scripts as part of the whole piece of software, rather than just auxiliary code.
I wanted to just follow up really quickly on that, because I think you make a really interesting point, and I've observed in the Scala community that actually it's pretty common to have configuration languages that are actually written in Scala. For example, the Scala build tool. I believe the Scala build tool does this.
Yeah, that's right.
I don't know if you have thoughts on kind of whether, does this solve a part of the configuration problem? I'm sure it doesn't solve all of it, but
So I think it helps within that particular language, and I would love to talk to you further, so we can talk later about what you've been doing. But there are going to be some of the same challenges. Now you have these configurations, right? So what do you do with them? So people leverage them for testing. They leverage them when they're doing evolution, when they're trying to. I don't know how much. I guess there is a traceability. So if it works in Scala, then can you abstract that higher to more general techniques and share that in a way that can get used across other systems, right? Because it's similar to people that use ifdefs, right? And it's similar, and that's what we're seeing inside of the busy box, but yet everybody's doing this in their own place.
Yeah.
Just interrupt me if you need to, Paul.
How can we reduce the number of configuration options? So it seems like if you improve documentation and tooling and whatnot, the problem might get worse. So just thinking about refactoring and improving the structure of a software and maybe reducing the number of configuration options is a really, really important part. I know that it's sometimes we cannot decide what to do, so we make it an option. So more people are happy maybe with the design decision, but how can we maybe get rid of unwanted configuration options?
It's a fantastic question. And there's actually been papers and actually user studies with developers to see, why they have these configurations and how hard it is for them. I am going to answer and say it's human nature. We want that flexibility. We want to be able to do things. I completely unrelated to this. I was just working with somebody who were working on a problem, an invariant problem. And the person who built the invariant tool for us, who's part of our research team, started out with a simple tool, and we now have at least 5 or 6 different options on it. And it's just a simple research tool, because every time we think of some new feature or some new thing we want to do, it gets added. Now, eventually you need to cull those, but then you also have a risk if they're not part of the if they're not thought of as part of the system, that you start removing code, and then you have these issues with inconsistencies between the options at the top level and what's underneath. But I don't have a good answer. People have looked at it. I think we want to give people as much flexibility. I know I do it. If you give me a system and I can't do something that I'm used to doing on something else, like with some command line or some other way, I want to be able to do it the way that I'm used to doing it. And everybody seems to have a different option. So I think it's just us. I don't know if there's an answer, but that's my opinion. Maybe I guess somebody else. I don't know, Paul, do you have
So
another
the
answer?
one comment I can say is that, I mean, it's basically just a software debloating question. You have the same problem even just with software. So I kind of take the view that configuration options, they're really just program variables. They just may happen to be defined somewhere else or used by multiple programs in your system. And so it really just is the software debloating question. You can run workloads and trace your program and see whether those options are ever used. I mean, that could be risky if a future user doesn't want to use them. But to me, it's really just a software debloating question. Can you kill your darlings and get rid of code that you don't think anyone will use? That's kind of a non-answer, but.
Hi, I think there are some analogs in day-to-day industrial software engineering. So you can look at build systems where you're pulling source code off other places as being a form of configuration, and this has caused some problems recently. And so there's a number of initiatives in that space. So there's SBOMs, so software configuration, bills of materials, and there's a bunch of stuff happening in that space. Different languages make it easier or more difficult to do that. The other thing that came to mind is that this lands up being quite a big problem in kind of just like configuring dev environments, etc. And so there's a bunch of options in that space, Nix, DAL, a whole lot of options in that space. And one of the interesting things about those good solutions in that space is that they're purposely constrained. They're not programming languages, and they want to be total. They want to be provable. They want to know that they can do it fast, and they want to know that they can do it reproducibly, and they want to know that other people can't inject stuff in. And yeah, it's a configuration space of software itself. So I don't know how that might help. And I have no idea where that stuff. Actually, Nix gets published, does publish stuff. But I think there's an entire other. I think you're tip of the iceberg.
and I think that's the point, is that they're probably doing very useful work there. And so like the security community also does use very constrained configuration, very options. So, you have to lock down to sort of control that interface. You want to lock down configurations, but then things get through. So you might leave, for instance, certain options open for debugging and then forget to close them, or you might have to leave some open for other things. So I think other communities are doing that, but my comment is I'm going to look at that work and I'm very interested, but I think that's the problem, is I don't know about all that work. So I want to go find it all, and it's all in different places, and they're probably have some great solutions that I can use and that other people can use. So how do we find that? How do we get it in one spot, right? So they're going to work on it and they're going to solve it in their community. How do we get it all into the same community? I don't know if there's a way to do it, but just configurations, right? Everybody, because it's the same problem, right, that usually you're solving.
Yeah, it's the same thing with the smell.
Right. So how do we? Yeah.
Just a quick counterpoint to we have too many configurations thing. So I worked at a project at Microsoft that was concerning feature flags, which are basically just configurations in the Microsoft Office code base, and they're really useful. Because the more we have of those, the more we can do experiments in production. We can do A/B tests. We can guard certain features behind flags and so on. And so in Office, there's any given day, there's 12,000 of these flags that are active. And of course, that is a problem that there's so many, but it's like we can't really reduce them because we need them. They are necessary to some extent. The problem then becomes how do they interact and what do they do and so on, right? So I think just reducing the number of flags, that's not a solution. That might be a solution in certain cases for certain applications, but in the broader sense, right, there has to be a way to deal with a lot of flags, right?
That's, I think, really.
Did they ever get rid of any? Like,
Oh yeah. There's like constant churn. There's like 12,000 flags on any given day in the code base, but it's not the same 12,000 one day to the next, because things get removed, things get added, but there's always going to be a massive amount that exists, and that is the problem. So that the project we were working on was about interactions between these configuration options and trying to find them, because the teams at Microsoft did not know which configurations existed and which their configurations impacted. That's the
right,
yeah. So I mean, this is all in that space. Yeah, just to add a data point.
Yeah, I think that's interesting, and even related to what the previous questioner pointed out. I think the problem is not so much, that there's too many configurations. It's that the ways of specifying them have largely been kind of ad hoc or homegrown. And so, you don't have anything that tells you the dependencies between the between feature flags, for instance. So in the same way, I always use object orientation as an example because, we're near OOPSLA. But in the same way that you can write an object-oriented style program in assembly if you really wanted, if you're really carefully documented your memory structures, you could do that. But when you have first-class constructs for defining these, you get the benefit of static checks. You have a machine-readable specification of it. And this has kind of been lacking with configuration language, more or less. There are definitely attempts to do it. And so if you could just the way you have type checking, if you had built-in specifications of your dependencies, for instance, you had to write them down or at least provide hints to the compiler, then they could be checked. The software engineering community has sort of done a lot in this, but it's not necessarily widely used. There's like feature modeling. This is more in the requirements space. So you always have to keep the code and the requirements matched up. It's not nice and built in like object-oriented code as much. I'm speaking in generalities, but I think that's really more the problem, is that if you can start formalizing and defining these languages, so the information about the features is defined in some language that's machine readable and machine checkable, then hopefully you can start tackling some of these problems in a more automated way.
Yes, this might follow up on that point you're just making, I think. And first, thank you for a very nice talk and a very good exposition of the problem. I wanted to say, in compilers, for instance, there are hundreds of flags and configuration options, and some researchers make a career out of using machine learning to explore the space and recommend the best configuration option for today. So I think you can perhaps do some people out of a job if you make
I may be guilty there. So I happen to know that the CC optimizer space is in the order of 10 to the 61 if you model it conservatively. So there are about 199 options just in the optimizer, which is the most complex part. There's thousands of them, but it's a huge space, and it's one of my favorite subjects actually to use for testing. But there are, because it's a really, it's a really hard system. There's tons of bugs left in it. But I know there are people that also build compiler testing and compiler fuzzing that also fuzz all of it. So it's a great example.
All right. Well, so I wanted to ask about the question of community. I like the idea of a more central resource. I mean, I think that you really point out the fragmentation of the research in this area, and I can relate. I've done a little bit of research on software architecture, which can be considered one form of configuration, and also thought about, could software architecture include some of these other forms of configuration, and what are the trade-offs? But it is hard to find all the information that's out there. There's websites and kind of online communities. I think of things like Slacks as being one form of that, is maybe the modern version of a mailing list, but also workshops that sometimes move between conferences and so on. I know you mentioned there are some workshops specifically on configuration. Are they specific to one of these communities, or do they move between them?
Yeah, no. So the one that's on configuration, so I just met somebody from that community, even though I've been working in configurations, and they're really more on the sort of systems level hardware configuration. Although I work a lot in cyber physical now, and it's, to me, it's a huge overlap, but they've been much more on that sort of hardware side of things. The product line community, which I participate in, has really been looking at sort of this managed software. Vamos is kind of closer to them, but they work on variability, more on the software side of things. But they're pretty much similar communities. But we have been talking, so Paul and I are talking about, could we start to do something to try to build some prototypes to see if somebody, if people in the community would be interested, would participate, so if you're interested in this topic, let us know, because we may try to see if we can get a variety of researchers in different domains that potentially, and at least meet and talk. We can either do it virtually or in person, and so we've talked about going to various communities and doing that, but we haven't.
Just a quick idea, we could have something like a showdown seminar.
Yeah.
Showdown has better food.
Yeah, so that's also and the thing is,
Shonan was the suggestion.
There have been dog stools on, so I haven't been to Shonan, but I'm going soon. But I have been to dog stool, and there have been ones on variability that was part of, and then there are ones on feature interactions. And I believe, Paul, you were supposed to go to one, but I didn't know anything about it. On on configurability with a slightly, so there's different. Even there's like a sort of a group, so you have to somehow announce it to get the right people so that you can cross. I think the one that was on feature interactions deliberately tried to get people from the requirements and the testing community together. But I think it's a great way to start, is to have something like that. I don't know. I think that dog show got canceled, right? That was a pandemic one, right?
Yeah.
Do you know who was in that community? That was a recent one, I think, right?
Yeah, I don't remember.
Because it's happening in February.
Oh, is it happening still? Okay, so there's one. Okay, so yeah, so that's, but it's still, I think they're still staying within a sort of small group, and they're focusing it. Whereas I'd like to see it with people from completely different communities, people who never publish in a software engineering community, who never or some people from programming language, software engineering, from the Usenix file systems, other sort of hardcore systems groups, some of the HCI, and really try to, I think that would be interesting. And I don't know how you go about applying for one of the, I've done a dog stool, I haven't done a shonen, but yeah, that'd be interesting to do.
All right. Well, we are at the end of the session, so let's thank Myra and Paul again.